we have these three non-collinear points, H, P and M. We had already seen that three non-collinear points always give us a triangle. Now joining these three non-collinear points, I get three sides of the triangle. Now the next question. Can these three sides be of any length? Well, try making a triangle with sides 1 centimeter, 4 centimeter and 5 centimeter. See if you can make a triangle with these three sides. Let us see. Now say you want to go from your house to the playground. We've already seen that from any curved line, the straight line is the shortest distance between 2 points. So this straight line HP is the shortest distance. In fact, if you want to go from your house to the playground, and rather than going directly to the playground, you go to the market first and then come to the playground, then obviously this is a longer route. This is precisely what the triangle inequality says. It says that HM plus MP would be a longer route. The distance would be more than HP if you go from your house to playground directly. Again, if you want to go from your playground to market, then this is the shortest route, the one that directly joins P to M. Rather than going from your playground to the house first and then coming from your house to the market, this is the shortest route. So PH plus HM would be greater than PM. Again, this holds for the third side too. Rather than going from market to house directly, if you go from market to the playground first and then from the playground to the house, then that's a longer route. So MP plus PH would be greater than MH. So we've seen that the sum of lengths of any two sides has to be greater than the third side. Note, I'm saying greater here. Can these sides be equal? Can the sum of two sides be equal to the third side? Let's see this. So it would be equal. We have HM plus MP should be HM plus MP is greater than HP. So when would HM plus MP be equal to HP? As soon as I start decreasing my M. So let's do that. What I'll do is I'll start decreasing my M such that HM plus MP becomes equal to HP. So let me decrease this M. So I keep decreasing. Still HM plus MP is greater than HP, which is a straight line. Now here you see that HM plus MP is equal to HP. So now I've satisfied the condition. But do I get a triangle now? These 3 points are collinear points, and collinear points do not give us a triangle. Hence, it is important that the sum of two sides should be greater than the length of the third side. It should not be equal to the length of the third. Now, we can look at it in another way also. So, say you have this triangle with points H, P and M. Try making a circle with H as a center. So, you get a circle. Now, with P as the center, draw another circle such that it just touches this circle. Now, let's look at the radius here. So, this is the radius. This purple line is the radius here. Whereas this yellow line is the radius of this circle with center P. So now, what is HP? This purple line plus this yellow line. What is HM plus MP? Purple plus yellow plus blue. Note that these two purple lines are the same because they are the radius. Radius has to be equal. These two yellow lines are also of the same length. So, I have this purple plus yellow plus blue here. So, clearly you can see that HM plus MP has this extra blue here, has a greater length, and hence it is greater than HP. Now, let's try to see when would this be equal to HP. So, when would this be equal to HP? When I don't have this blue. So, HP and HM plus MP will be equal. So, let's try to decrease this blue. Let's try to remove this blue from here now. Let's look at this. So, I'm decreasing my blue such that here, when I have point M here, I do not have blue. Here also I have a little blue. So, I keep decreasing my M till there is no blue left. Now, HM plus MP is equal to HP. But again, these 3 points are now collinear and hence it does not give me a triangle. So, now let's see. Now can you make a triangle with sides 3, 4 and 5? So, what you need to do is, what you need to check is that sum of 2 should be greater than the third. So let's take any two, 3 and 4. So 3 plus 4 is 7, which is greater than the third, which is 5, which is greater than 5. Let's take the other two now, 4 and 5. So 4 plus 5 is 9. And this is greater than the third side, which is 3. Now let's take first and third, which is 3 and 5. So 3 plus 5 is 8. So 3 and 5, the third side is 4. It is greater than 4. The sum of 2 is greater than the third. Hence, it is a triangle. So I can make a triangle with these three sides because it satisfies that sum of 2 is greater than the third. So now let's get back to the previous question. Can you make a triangle with sides 1, 4 and 5? Let's see. Sum of 2 should be greater than the third. We have 1 plus 4, which is equals to 5. Is it greater than 5? No, it's not. So this does not hold, and hence these sides would not give me a triangle. So we've seen for a triangle, we need that the sum of lengths of two sides should be greater than the third side. Now let's see how we classify these triangles according to the sides. So a scalene triangle. So scalene comes from the Greek word skalenos, which means unequal. So a triangle with three sides unequal is called a scalene. So here you will see that in both these triangles, all the three sides are unequal, and hence these triangles are scalene triangles. So isosceles triangle. Now isosceles comes from the Greek word isosceles, which means equal sides. So when two sides are equal, here you see 7 and 7, two equal sides. Again, here 6 and 6, two equal sides. So two equal sides, and hence an isosceles triangle. The third is an equilateral triangle. Now this word equilateral comes from a Latin word which is equilateralis, which means equal lengths. If all three sides are equal, then yes, I say that my triangle is equilateral. Note, to show equal sides, I use a slash here, I use two dashes. You can use a single dash too. So if I have a triangle here, and I put 3 dash here, so this signifies that all the lengths are equal, and hence it's an equilateral triangle. So even if the sides are not mentioned, and you just have this symbol marked here, you should get an idea that this would be an equilateral triangle with three sides equal. So basically what you learned from this lecture is that sum of lengths of any two sides in a triangle should be greater than the third side. And then we see how according to sides, triangles is classified. If three sides are unequal, all are different, then I say scalene. If two sides are equal, isosceles. If all three sides are equal, then it's an equilateral triangle.